Before we get started, just a reminder to everybody that this is my personal way of solving this problem. For me, this is an efficient and clear way of solving this specific math problem. I highly advise that you watch the entire video without skipping so you'll fully understand the step-by-step process of solving this math problem. Feel free to rewind any segment of the video. I hope this video will make things easier for any of your needs. Thanks and enjoy the video. In this video, we will solve the 2020 Mathematics Problem 1-3, and this will serve as a reviewer for the Graduate School of Engineering entrance examination of the University of Tokyo. The 2020 Mathematics Problem 1-3 is given like this. Express the general solution of the following differential equation in the form of f of x, y equals c, where c is a constant, using an appropriate function f of x, y. The differential equation is the quantity x cubed y to the nth power plus x quantity dy over dx plus 2y equals 0. X is greater than 0 and y is greater than 0. Let us call this as equation 3, where n is an arbitrary real constant. To start with this problem, we can first simplify the given differential equation. To start with this problem, we can first factor x from the first term. We can have x times x squared times y raised to n plus 1, then dy over dx plus 2y equals 0. Let us use this transformation. We'll let u equals x squared y raised to n, because x squared y raised to n might be difficult to integrate later on. In this case, if we have u equals x squared y raised to n, we can have du over dx. Applying product rule, we have x squared times n times y raised to n minus 1 dy over dx, then plus y raised to n times 2x. I use x squared as the left group and then yn as the right group. And applying product rule, we have left times derivative of the right plus right derivative of the left. So this is du over dx. We can further rearrange this expression to later isolate dy over dx. So we have du over dx minus 2xy raised to n equals nx squared y raised to n minus 1 dy over dx. And let us isolate dy over dx. We will have dy over dx equals du over dx minus 2xy raised to n all over nx squared y raised to n minus 1. Let us split into two terms. We can have 1 over nx squared y n minus 1 times du over dx minus 2y over nx. The x here and x squared will simplify to x in the denominator. And then y to the n divided by y raised to n minus 1 will give us y. Now, we can further extract y raised to n from this y raised to n minus 1. So we can later regroup x squared and yn to yield u. We can rewrite the first term as y over nx squared y to the n du over dx minus 2y over nx. You can see that x squared y to the n is our u variable. So we can rewrite again dy over dx as y over nu du over dx minus 2y over nx. So this is our dy over dx. And let us substitute that into this dy over dx of the original equation 3. So again, we have this expression for equation 3. We have x, and then x squared y to the n can be replaced by u and then plus 1. And then our dy over dx is y over nu du over dx minus 2y over nx. And then for the second term, plus 2y equals 0. As we can see from all the terms, we can cancel y. We can cancel y because y is defined to be greater than 0 and it will not render the equation undefined when we cancel y. So we can cancel y, and also y. Cancellation of y will give us x times u plus 1 quantity 1 over nu du over dx minus 2 over nx plus 2 equals 0. Next, let us rearrange and distribute the expression. So we have x times u plus 1 over nu du over dx minus 2x u plus 1 all over nx plus 2 equals 0. You can see that x will cancel. Next, let us multiply nu to all the terms. So we have x u plus 1 du over dx minus 2, then nu u plus 1 all over n. We can cancel n here. And then plus 2 nu equals 0. Now, let us rearrange this equation. X u plus 1 du over dx equals 2u times u plus 1 minus 2 nu. And then, the next step is divide all the terms by u plus 1. So we have x du over dx equals 2u times u plus 1 minus 2 nu all over u plus 1. Or we can distribute the numerator. We have 2u squared plus 2u minus 2 nu all over u plus 1. Or we can factor out the numerator as 2u times u minus n plus 1 all over u plus 1. So this is equal to x du over dx. Now, we can combine all the variables in u on one side and all the variables in x on the other side. So we will have in this expression u plus 1 all over 2u u minus n plus 1 du is equal to 1 over x dx. In this equation, it will be easier to integrate as compared to the original equation. For example, on the right-hand side, we can simply integrate this as ln of the absolute value of x plus c. Now, the current problem is how do we integrate the left-hand side? So what we will do is we will perform partial fraction decomposition for this group, so it will be easier to integrate. So we have u plus 1 all over 2u times u minus n plus 1. We can perform partial fraction decomposition by having a over 2u plus b over u minus n plus 1. We can recombine them as a times u minus n plus 1 plus b times 2u all over 2u times u minus n plus 1. We can distribute the numerator as au minus an plus a plus 2bu all over 2u times u minus n plus 1. And this is equal to the original equation, u plus 1 all over 2u, u minus n plus 1. So what we need to do is to compare the coefficients of u and 1. Comparing the constants coefficients, we have 1, this negative an and a. So our equation is negative an plus a is equal to 1. Or we can have a times 1 minus n equals 1. Therefore, a is 1 over 1 minus n. Next, we compare the coefficients of u. So u here has coefficient of 1, and then u has au and 2bu. So we have au plus 2bu equals u. So we cancel all the u. We have a plus 2b equals 1. So from here, we have 2b equals 1 minus a, but we already obtained a. So we have 1 minus 1 all over 1 minus n. This is the same as 1 minus n minus 1 all over 1 minus n, which is equal to negative n over 1 minus n, or simply n over n minus 1. So in this case, we have b as 1/2 of n over n minus 1. So we have performed the partial fraction decomposition. Therefore, we have u plus 1 over 2u times u minus n plus 1 as a over 2u. So we have 1 over 1 minus n times 1 over 2u. And then we have b, 1/2 of n over n minus 1 times 1 over u minus n plus 1. And then we can perform integration. Therefore, the integral of u plus 1 all over 2u times u minus n plus 1 du is equal to the integral of 1/2 times n over n minus 1 times 1 over u minus n plus 1 du. This is from the second term. And then for the first term, we have plus 1/2 times 1 over 1 minus n times 1 over u du from the first term. Also, from the right-hand side of the original equation that we have derived before, this is equal to ln of x plus c. And this is easier to evaluate. So we have, for the first term, we can easily extract 1/2 and the group n over n minus 1. So we have 1/2 n minus 1. Then ln of u minus n plus 1. And then for the second term, we can extract 1 half and 1 over 1 minus n. So we have plus 1 half times 1 over 1 minus n. Integral of 1 over u du is ln of u. And this is equal to ln of x plus c. We can further clean this equation. We multiply 2 to all the terms. So we can cancel 1 half, multiply by 2, and then the 2 will be absorbed in this constant. And then we put the original expression for u. Recall that we have used u equals x squared y to the n. So we can further rewrite as n over n minus 1 ln of the absolute value of x squared y to the n minus n plus 1 plus quantity 1 over 1 minus n ln of the absolute value of x squared y to the n. And then let us transpose this term as minus 2 ln of absolute value of x equals c. And we can further rearrange this expression by cleaning the signs and the order of this expression. So overall, we can express the desired function f of x comma y as 2 ln of x plus 1 over n minus 1 of ln of x squared y to the n minus n all over n minus 1 ln of x squared y to the n minus n plus 1 equals c. So we can have this as the general solution to our original differential equation. And that's it for this video. If there are any questions, go on and leave a comment down below. I'll answer all your comments as soon as possible. If you want to see more videos from a somewhat unconventional small YouTuber, make sure to subscribe to this channel. Leave your thoughts down in the comments and turn on the post notification by clicking that bell button. Thanks, and I'll see you in the next video.